When dealing with low-voltage power circuit breakers in facilities such as pulp and paper mills, a common practice is to lock out sections of the process using these breakers. A typical policy involves opening the breaker, racking it out, and then locking it in the disconnected position. This approach aims to eliminate the chance of the circuit remaining energized due to a breaker failure. However, it also introduces challenges, particularly concerning safety and maintenance. Racking the breaker out and back in can expose personnel to an arc flash hazard, especially with older breaker designs that require the door to be opened during racking. Additionally, the repeated racking motion can cause wear and tear on the racking mechanisms, potentially shortening the breaker's lifespan. An alternative method involves opening the breaker and locking it in the connected position. Breakers often have provisions for this, such as a tab that can be pulled out and secured with padlocks to prevent closure. The argument is that this method is similar to locking out a disconnect or molded case breaker, where one relies on the switch remaining open after testing for voltage. However, manufacturers may be hesitant to endorse this method, even if the breaker design allows it. There are several factors to consider when deciding on the best lockout procedure. Firstly, safety considerations are paramount. Racking out the breaker poses an arc flash hazard, especially if the breaker is not properly energized beforehand. Opening and locking the breaker in the connected position also carries an arc flash risk if the breaker malfunctions and unexpectedly recloses. Secondly, the reliability of the lockout method is crucial. Locking the breaker in the connected position depends on the integrity of the breaker's mechanical interlock mechanism. Failure of this mechanism could lead to the breaker being mistakenly closed while locked, creating a significant electrical hazard. Thirdly, maintenance considerations come into play. Repeated racking can wear out the racking mechanism, reducing the breaker's lifespan. Additionally, arcing during racking can erode the breaker's contacts, decreasing reliability and increasing maintenance frequency. To mitigate these risks, several alternative options and best practices can be implemented. One option is to always test the circuit for voltage using a qualified voltage detector before racking out the breaker. This practice significantly reduces the risk of an arc flash hazard. Another option is to utilize breakers with remote racking capabilities, which allow employees to rack the breaker without opening the door and exposing themselves to potential arc flash. Infrared scanning can also be used periodically to check the breaker for hot spots, which can indicate problems with the breaker or its connections. When determining the best lockout procedure, it's essential to follow the manufacturer's instructions. Consult the breaker manufacturer's guidelines for the recommended lockout procedure, as they are specifically designed for the equipment in question. A thorough risk assessment should be conducted to determine the safest and most effective lockout method for the specific breakers and the work environment. This assessment should consider the potential hazard and the likelihood of occurrence, as well as the effectiveness of various mitigation measures. Employees should receive comprehensive training on proper lockout procedures and the associated risks. Training should cover the correct use of lockout devices, the importance of verifying de-energization, and the procedures to follow in case of an emergency. Appropriate personal protective equipment, or PPE, must be worn by employees when performing lockout procedures. This includes flame-resistant clothing and face protection to minimize the risk of injury in the event of an arc flash. Regular inspections of breakers and lockout devices are necessary to ensure they are in good working order. Inspection should include checking for signs of wear or damage, verifying the proper operation of interlock mechanisms, and ensuring that lockout devices are readily available and in good condition. The decision to rack out breakers or lock them in the connected position should be based on a comprehensive risk assessment that carefully weighs both safety and maintenance factors. While locking the breaker in the connected position may reduce the arc flash hazard and minimize wear on the racking mechanism, it introduces the potential risk of the breaker malfunctioning and reclosing unexpectedly. Following manufacturer's instructions, performing thorough risk assessments, providing comprehensive employee training, and using appropriate PPE are all essential components of a safe and effective lockout procedure. When implementing lockout procedures, it is crucial to adhere to established safety standards and regulations such as those outlined by the Occupational Safety and Health Administration, or OSHA, and the National Electrical Code, or NEC. These standards provide detailed requirements for lockout/tagout procedures, including the use of specific lockout devices, the verification of de-energization, and the training of employees. One of the key elements of a successful lockout program is the development of written procedures for each type of equipment and situation. These procedures should clearly outline the steps required to safely de-energize, isolate, and lock out the equipment, as well as the steps for verifying de-energization and releasing the lockout. The procedures should be readily available to employees and reviewed periodically to ensure they remain accurate and effective. Another important aspect of lockout procedures is the proper use of lockout devices. These devices are designed to physically prevent the equipment from being energized while maintenance or repair work is being performed. Common lockout devices include padlocks, tags, and circuit breaker lockouts. It is essential to use the correct type of lockout device for each application and to ensure that the devices are properly installed and secured. Verifying de-energization is a critical step in the lockout process. Before any work is performed on de-energized equipment, it is essential to verify that the equipment is indeed de-energized and will not become energized unexpectedly. This can be accomplished by using a qualified voltage detector to test the circuit for voltage. It is important to follow the manufacturer's instructions for the voltage detector and to use it in a safe and proper manner. Employee training is an essential component of any successful lockout program. Employees must be trained on the purpose and function of the lockout program, the procedures for locking out equipment, and the hazards associated with working on energized equipment. Training should be provided to all employees who may be involved in lockout procedures, including maintenance personnel, operators, and supervisors. In addition to initial training, refresher training should be provided periodically to ensure that employees remain proficient in lockout procedures. The lockout program should be regularly audited to ensure that it is being implemented effectively and that it is meeting the requirements of applicable safety standards and regulations. The audit should include a review of the written procedures, an inspection of lockout devices, and interviews with employees to assess their understanding of lockout procedures. Any deficiencies identified during the audit should be promptly corrected. When evaluating the two lockout methods, racking out the breaker versus locking it in the connected position, it is important to consider the specific characteristics of the equipment and the work environment. Racking out the breaker provides a positive physical disconnection of the circuit, which can provide a greater level of assurance that the circuit is de-energized. However, it also exposes employees to the arc flash hazard associated with racking the breaker. Locking the breaker in the connected position relies on the integrity of the breaker's internal mechanisms, which can be subject to failure. However, it eliminates the arc flash hazard associated with racking the breaker. Ultimately, the decision of which lockout method to use should be based on a comprehensive risk assessment that considers all of the relevant factors. The risk assessment should take into account the specific hazards associated with each method, the likelihood of those hazards occurring, and the potential consequences if they do occur. The risk assessment should also consider the capabilities and limitations of the equipment, the training and experience of the employees, and the overall safety culture of the organization. In some cases, it may be appropriate to use a combination of lockout methods. For example, the breaker could be racked out and locked in the disconnected position for certain types of maintenance work, while it could be locked in the connected position for other types of work. The specific lockout method used should be determined on a case-by-case basis, based on the results of the risk assessment. It is also important to consider the potential for human error when implementing lockout procedures. Even with the best written procedures and the most reliable equipment, there is always the possibility that an employee will make a mistake. To minimize the risk of human error, it is important to provide employees with clear and concise instructions, to use simple and intuitive lockout devices, and to provide ongoing training and reinforcement. It is also important to encourage employees to speak up if they have any questions or concerns about lockout procedures. By creating a culture of safety and encouraging open communication, organizations can significantly reduce the risk of lockout-related accidents. In addition to the safety considerations, it is also important to consider the economic impact of lockout procedures. Lockout procedures can be time-consuming and can disrupt production. Therefore, it is important to strike a balance between safety and efficiency when developing and implementing lockout procedures. One way to improve the efficiency of lockout procedures is to use standardized lockout devices and procedures. This can help to reduce the time required to lock out equipment and can also help to reduce the risk of errors. Another way to improve the efficiency of lockout procedures is to use technology. For example, some organizations use computerized lockout systems that can help to track lockout devices and to ensure that equipment is properly locked out. Technology can also be used to provide employees with real-time access to lockout procedures and other safety information. In conclusion, the decision of whether to rack out breakers or lock them in the connected position should be based on a thorough risk assessment that considers both safety and maintenance factors. Following manufacturers' instructions, conducting risk assessments, training employees, and using appropriate PPE are essential for ensuring a safe and effective lockout procedure. By carefully considering all of the relevant factors and by implementing best practices, organizations can minimize the risk of lockout-related accidents and can create a safer and more productive work environment. When evaluating the two lockout methods, it is essential to consider the specific context of the facility and the equipment involved. Factors such as the age and condition of the breakers, the frequency of maintenance, and the skills and experience of the employees can all influence the optimal lockout strategy. For example, in older facilities with aging breakers, it may be more prudent to rack out the breakers to ensure positive physical disconnection, even if it increases the arc flash risk. In newer facilities with more reliable breakers, locking the breakers in the connected position may be a viable option as long as the mechanical interlock mechanism is properly maintained and inspected. The frequency of maintenance can also impact the lockout decision. If breakers are frequently racked in and out for maintenance, the wear and tear on the racking mechanism can become a significant concern. In such cases, locking the breakers in the connected position may be a preferable option as it reduces the stress in the racking mechanism. The skills and experience of the employees are another important consideration. If employees are not properly trained on lockout procedures or if they lack experience working with electrical equipment, it may be more prudent to use the more conservative approach of racking out the breakers. In addition to these factors, it is also important to consider the potential for complacency. Over time, employees may become accustomed to lockout procedures and may become less vigilant about following them correctly. To combat complacency, it is important to provide ongoing training and reinforcement to regularly audit lockout procedures and to encourage employees to speak up if they have any concerns about safety. By fostering a culture of safety and continuous improvement, organizations can ensure that lockout procedures are implemented effectively and that the risk of accidents is minimized. In some cases, it may be beneficial to consult with a qualified electrical engineer or safety professional to develop a customized lockout strategy that is tailored to the specific needs of the facility. These professionals can provide valuable insights and recommendations based on their expertise and experience. They can also help to conduct risk assessments, develop written procedures, and provide training to employees. By working with qualified professionals, organizations can ensure that their lockout procedures are compliant with applicable safety standards and regulations and that they are effective in protecting employees from electrical hazards.